everyone. I got three difficult questions, math questions that require some geometry and algebra to solve. So let's get started. So the first question is three circles on the same side of a common tangent line are exterior tangent to each other. Find the radius of the smallest circle if the large circles have the radii of 2 and 4. So whenever we have these kind of external tangent circle questions, we first want to connect them all. So let's first do that, connecting A with B, B with C, and A with C. And then the way I'm going to approach it is gonna draw some more lines like this. From here, we know that the length of AC is going to be 2 plus 4, which is 6, because it's connecting the two large circles' radius, right? And let's say that the radius of the small b circle is r. Then the length of AB would be 2 plus r, and the length of BC would be 4 plus r. Same concept, we're connecting the radiuses together. And we also know that the length from the A to this little part is 2 minus r, since we're subtracting the B radius from the whole A radius. And same concept, the length of here would be 4 minus r as well. And what I'm also gonna do is connect like this. And this length would be so we'll rewrite this as the length of C, and this, let's call it H here. The length of CH would be 4 minus 2, because remember, here is 4, and from here it's 2 from the radius of the A circle. So in result, the length of CH would be just 2. And that would mean that the length of here, the rest, would be 2 minus r. Then we could use the Pythagorean theorem to calculate what AH is. This is root 36 minus 4 equals root 32, which is equivalent to 4 root 2. That means that the length of here, let's call it K and P. The length of K, this is also equal to the length of K and P. It is the same thing. And we could also find, let's call this point O. We could find the length of KO, because KO plus OP would equal to KP. So if we want to find the length of KO, KO would equal to root of AB squared minus AK squared using the Pythagorean theorem, which is root r squared plus 4r plus 4 minus r squared minus 4r plus 4. Our length of OP would be using the Pythagorean theorem of the triangle OP and C. So if, well, not OP, OP, or just, well, always like same thing as B, right? So I'll just make that correction here. So yep, like this. Yeah, always just to reference B, but I guess so. BP would be root BC squared minus CP squared, which is equivalent to root r squared plus 8r, because remember CP for BC is r plus 4, 16, minus CP squared, which is r squared minus 8r plus 16. And remember, we are adding these two values to get Kp, which was 4 root 2. So let's first simplify this even more. This simplifies to r squared gets cancelled and 4 gets cancelled. So we are left with 8r. And here, again, cancelled and 16 cancelled. And we are left with root 16r. So if we add these together, root 8r plus root 16r, this should equal to 4 root 2, because that's what Kp is. So if we multiply these, or the same thing, both sides, square them both sides, we could get 8r plus 16r plus 2 and multiply the two insides, which is 128r, and this should equal to 32. This is 24r plus, if we simplify this, we get 128 is a squared times 2, so that a could go outside, making 16. And also I forgot a squared here, so 16r root 2, which is equal to 32. Now since this is, we could divide both sides by 4, or we could also divide it by 8. So to simplify even more, we get an equation something like this. And now we could group the r's as they're the same in both. We get something like this, and our r would equal to 3 plus 2 root 2 in the denominator and 32 in the numerator. And since these are not one of our options, we need to simplify it even more. So we will multiply both sides by the congruent, which would give us 9 minus 8, which is just 1, over, oh, also, I forgot to divide both sides. I only divided one side. So it will be something like this, right? This will be 32, and we divided by 8. So we need to do divide by 8 as well. So this is supposed to be 4. And if we multiply 4 with 3 minus 2 root 2, we get 12 minus 8 root 2, which is 12 minus 8 root 2. And that would be our final answer for this question. Question number 16. N factorial, that's how we read it, is the product of the first n natural numbers. So n factorial would equal to 1 times 2 times 3 times to multiplying till n. Then the question asks 2023 factorial over 2021 factorial plus 2022 factorial. So let's first lay this into a form of multiplication first for better understanding. So this is same thing as 2023 times 2022 times 2021 up to multiplying by 1 over 2021 multiplied by 2020 multiplying till 1, and we add the factorial of 2022. So as we can see, we could actually group something to make it even simpler, because this red equation is the same thing as this red equation. So, and remember, this red equation is 2021 factorial. So if we group the denominator, 2021 factorial, this will just be 1 plus 2022. And the numerator would be just 2023 factorial. But this 2023 factorial could also be divided into 2023 times 2022 times the rest, which is 2021 factorial, over 2021 factorial, oh, I'm getting mixed up, multiplied by 2023. And surprising enough, we get a bunch of cancellations. So our final answer would just be 2022. C. Heading on to the final question. For certain real numbers a, b, and c, the polynomial gx equals x cubed plus ax squared plus x plus 10 has 3 distinct zeros, and each zero of gx is also a zero of the polynomial fx equals x to the power 4 plus x cubed plus bx squared plus 100x plus c. So the question is asking what f1 is equal to. So since we know that each zero of gx is also a zero of fx, we could write fx equals to gx and multiplied by some kind of x plus, for example, k. We would not know what the k is from here, but since they share the same zeros, we could represent it as this. So fx is x to the power 4 plus x cubed plus bx squared plus 100x plus c equals to x cubed plus ax squared plus x plus 10 multiplied by some x plus k. And if we compare the coefficients of x cubed, since the coefficient of x cubed here is 1, then the coefficient of x cubed in the right side of the equation should also be 1. And if we expand this just for the coefficients of x cubed, multiplying these two and multiplying these two are the only coefficients of x cubed, which is ax cubed plus kx cubed. And this should equal to, I'll write on the left side, to x cubed. So we know that k is equal to 1 minus a. So using this, we could also look at the coefficients of 100x, because 100x is same thing as here, x times k and 10 times x. 100 equals to 10x plus kx. And since we know that kx is equal to 1 minus a, we now know that 100 is equal to 11 minus a. Therefore, a is equal to minus 89. Since we already found the value of a, our gx is we found what the function gx is. It is x cubed minus 89 x squared plus x plus 10. And we know that fx is equal to gx times x plus k was same thing as x plus 1 minus a, and x plus 1, and since a is equal to minus 89, we just simply plug it in and we get plus 90. Yep. And this equation came from here as well. So if we calculate this, the question is asking for what F1 is. So F1 would be equal to G1 multiplied by 91. And G1 would be easy to find because we could find G1 from this equation. G1 is equal to 1 minus 89 plus 1 plus 10, which is equal to minus 77. So if we plug in minus 77 into G1, our F1 would equal to minus 77 multiplied by 91, which gives us, if we calculate this, you could do it on a calculator, but I would just multiply this. 763, 763. We get 7007, negative 7007, which is C, our final answer. So in this video, I just combined 3 different random math contest questions, and I hope you guys enjoyed and learned something new today. Thank you.